Whenever you're designing your own experiment, you want to be aware of something called sample size. Sample size is the number of treatments or replicates you have in your experiment that's helping you demonstrate a pattern. The reason why sample size is important is that sometimes patterns aren't obvious when you have a small number of treatments or a small number of replicates. A great way to demonstrate that is using a coin. We intuitively know that we should get heads 50% of the time and we should get tails 50% of the time. But if you only flip a coin once or twice, that pattern might not be so clear. So let's look at that a little more closely. To demonstrate the effects of sample size on our ability to see a pattern, let's look at the proportion of heads to the number of flips. So for this example, let's consider heads as equal to 1. And tails, we're not going to worry about tails. So the first thing you'll do is make a table. And this table should be about 12 spaces tall by 3. On the very left column, you're going to have the number of flips, and that's the number of times you're flipping the coin. We're going to flip the coin, and these are your treatment numbers. We're going to flip the coin once, twice, 3 times, 4, 5, 6, 7, 8, 9, 10, then 20, and finally 50 times. Then we're going to record the number of times it lands on heads. And finally, in this last column, we're going to have the ratio of heads over flips. For example, if you flip the coin 2 times and you get heads once, then your heads over flip value will equal 0.5. 1 divided by 2, and then you would put that in this column over here. Let's fill in some example data here. Let's say you flip it once and you get heads 1 time. That means your heads over flips is 1 heads over 1 flip, that equals 1. Let's say you flip it twice and you get 1 heads again, so that means 1 head out of 2 flips equals 0.5. Let's say you flip it 3 times, and this is, I'm just making this data up. Let's say you get 3 heads, so you get 3 out of 3, then you get a value of 1 again. In this last example, let's say you get 3 heads, so you get 3 heads out of 4 flips, that equals 0.75. So where do you put this data when you're all done? To show the pattern, we're going to make a graph. Now the graph should be as tall as the maximum value here on this side here, so that's 1. So let's split that up into 10, so let's make it 10 units tall. So this value will be 0, this will be 0.1, 0.2, and in this case 1 is the same as 100%, and then 0.5 is the same as 50%, and 0 is, well, yeah, 0%. That's your y-axis. For your x-axis, we'll record the number of flips, and we'll give it 2 spaces, so that's 1 flip, 2. Now remember, you have to label your axes, so here we'll do the heads over flips, and then on your x-axis, the number of flips. You also want to title your graph. So let's call this graph the proportion of heads versus flips. When filling your data out, simply match the number of flips. Here you have your first example, it's the number of flips, 1 flip, with the value you got. So with our first flip, we got heads, so we got a value of 1. So we just go up here to 1, and we mark it here. We put a data point there at 1. Now for 2, with our example data, we got a value of 0.5, so we're going to put that here. And we find 0.5. Let's put 0.5 there. And for 3, we got 1 again, so we mark that up here at 1. And then for 4, we got 0.75. So we're going to put that mark right about here. And when you're done, you'll want to connect these data points and complete this graph. So you should have a bunch of points and they should all connect somehow, but that's up to you to see how. So to finish this assignment, you'll be filling out the table on the left in your notebooks and you'll finish the graph on the right in your notebooks. Remember that these are independent treatments, so when you have a number of flips, that's a new number of flips. For example, if you have 2 flips, you'll be flipping the coin twice and recording the data for that. When you have 4 flips, you'll flip the coin 4 times and you record the number of times it's heads for that. And finally, when you have 50 flips, you'll flip the coin 50 times and record the number of times it's heads for that treatment. Each one of these treatments is an independent new number of flips. Make this graph in your lab notebooks, and then you'll be uploading a picture of your finished graph at the end of the assignment.